First of all, I always ask the question, who knows Eaton already? So I see some, a lot of fingers going up. So, but for the other ones, who doesn't know Eaton or are not so familiar with Eaton? So we, as Eaton, are dealing with power management. Power management is that what we're dealing with every day, and we try to make the energy transition work. Power management doesn't only mean electrical power. We are also working with fluid power, for example. One of our really strong portfolio is for hydraulics, for example, for stationary and mobile applications. If you think about big stamps or producing the metals for cars, for example, the big stamps are driven by hydraulic applications. And also we are a provider and component provider for aerospace. So some valves, some pumps in the, for example, Airbus A380. But we are now in the electrical components. From an electrical side, we have experienced more than 100 years electrical distribution and more than 20 years in UPS. Electric distribution means everything from medium voltage to low voltage. Basically, even everybody of us at home has a MCB or MCCB at home, which is protecting every connector, every switch. So we can supply these. And as well, we're supplying UPS systems, so we are backing up IT systems, uninterruptible supply, so that the computers at home don't switch off in case of there's an outage of the grid. But we also have large-scale UPS. We are protecting finance, banks, data centers, that they don't shut off. So having this kind of experience in electrical, in power management, so we decided a couple of years ago to develop our storage solutions. What you see on the booth over here are storage solutions from residential application we are now talking to, up to large scale. So what you see over there, maybe if there's any interest later on, I can show you some projects we already, and some results of the projects we had a couple of years ago already. So for example, Amsterdam Arena, the whole stadium is running on a 2.8 megawatt hours storage solution. But we are now talking about our storage solution, which is for residential applications. You see it over here. The only difference between the one which will be implemented in the house is that this is not a transparent cover. This is just for the fair. Basically, what are the key facts of this system? This is an all-in-one system. It's not just a storage system, it's also a PV inverter inside. So what you see, it's a combined one, it's a hybrid inverter. Hybrid inverter, what does it mean? So we got the PV connection, and now I'm gonna take off the cover to see really the two different components. Just 1 second. Thank you. So you see it over here. Over there, it's a hybrid inverter. This is the battery pack. First of all, the battery pack. It's a one frame size. We can choose between 3 different capacities. So it's 4.2 kilowatt hours, 6 kilowatt hours, or 10 kilowatt hours, all on the same frame size. It's just different technologies what we implement from the batteries. The batteries are our battery supplier. We're cooperating with Nissan. Nissan, I think everybody of you knows Nissan from the automotive side. They are the most, they're the leading manufacturer of electric vehicles, and at the same time they develop their own batteries. They produce their own batteries. So we have 2 different options. Either we have new batteries coming from the production from Nissan, or we have so-called second life batteries. So Nissan is replacing the batteries of an EV car after a certain capacity. So it goes under a certain capacity. Nissan will exchange the battery to keep the distance to drive, and they will bring the batteries back to our facility. We will disassemble the batteries, check the quality, build them together on the same quality level, and then build these stationary storage systems. Then connected to our inverter. The inverter has over here, maybe some of you are familiar with MC4 connectors. you can directly plug in the PV, and on the lower connector blocks you have two connections. The first connection is, of course, the household. The second connector block is backup load. So one big feature in case of a grid outage, the system can switch over in less than 50 milliseconds, around about 20 milliseconds, can switch over to the critical loads. Critical loads could be like heating, like refrigerators, like lights. You want to stay on even if the grid is not there anymore. So you then can decide, even in the software, you can decide to set up a different level of how much energy should be stored in the storage. So just reserve this one in case of there's an outage. Especially in some other countries, this application is really famous. If we now go on the interface, what we're showing over here, this is a live interface built in our facility. You can access this with any kind of device, so it's a web application. So it doesn't matter if Android, iOS, or even if a computer. And it shows you on the first screen already what is the charging station of the battery and what is connected. You see on the upper left-hand side, you see your PV production. On the right-hand side, the grid connection. On the lower right-hand, the house consumption. And then on the left-hand side, on the lower left-hand side, you see what your critical loads at the moment are provided with how many energy. And then, of course, you can, just as an overview, you can see different graphs. If you want to see it over the day, what was my production over the day and my consumption over the day. What has been over the months, over the years. So really, if you want to analyze how was your behavior depending on the energy, you can easily see this one. And even if you get alarms or anything else, you will see this. And you can even set up a schedule. If you are there and on the heating, mostly it's called party mode. So if you want to heat instead of changing the schedule, you can then say, okay, at the moment I will be on vacation, for example, so just load or put the PV into the grid because you get feed-in tariffs. You're flexible to override the existing mode. And of course, what we see on the lower left-hand side, it's the fitting EV charging station. For Germany, this is at the moment is a big trend to implement charging stations already because EV cars are coming more and more familiar to the German market. And this is a charging station that's coming up from a cost-efficient version, single phase, up to really for commercial buildings, connected one where you have a master and a slave where you can control the different loads of up to 15 different charging points. So there's starting from a cost-efficient one up to a complex application where you have a whole fleet, for example, to charge. Yeah, these are the features. Do you have any questions so far? I'm always looking at the timekeeper.
Can you connect this vehicle charging switch with the inverter, or?
At the moment, you mean the connection to communicate? There is a communication could be done, but the fully implementation of the connection and the communication will be done in the next step, which will be available soon. So to directly communicate. What we already have available, we have our own building automation system, which is called xComfort. It's RF communication to have a building automation like control your heating, control your shadows, for example, connect everything to a smart home controller. The charging station is already connected to this one. It's already implemented into the software, and you can control this with an app.
So, Mr. Zimmermann, are there any questions? So I thank you very much.